going to be working on basic math fundamentals, specifically solving equation. And most students, especially math students, they don't like algebra because they've got letters in their word problems or in their regular equations. But really, solving equations is really simple. It's just another way of presenting a math problem, so it could be a little bit more flexible so that you'll be able to do more with equations and word problems in algebra. Now, to work out problems involving math equation, it's extremely important that you have mastered your multiplication table, because this is key in gaining more confidence with working on math problems, no matter how basic or complex it is. Also, your integers. Integers are also important because a lot of students take integers for granted because they think that it's really simple, and they don't really dwell on mastering adding, subtracting, multiplying, and dividing integers. So again, integers is basically visualizing the number line, both the positive and the negative values, in adding, subtracting numbers like this. So if you could answer 1, 2, 3, 4 with confidence and with accuracy, then I could assure you that you can easily answer any type of equations in basic algebra. So see if you can answer all 4 of them. So some of the equations here are easy to solve. Some can be a little bit tricky and will make you think for a little while. 7 minus 2 is pretty simple because it's pretty straightforward. 7 minus 2 is starting from 7. You will move 2 units going to the negative side. So 1, 2, it's going to be equal to 5. And if we're going to be working with 3 minus 8, 3 minus 8 is not 5. It is negative 5. Why? Because you start at positive 3 and you move 8 units to the negative side. 1, 2, 3, 4, 5, 6, 7, 8. And the answer is negative 5. And you know that 5, which is here, is not equal to negative 5. So it's not enough that you are getting the correct number. You need to make sure that you are also using the correct sign or the integers that you're working on in an equation. That's why the mastery of the number line is extremely important. So if I have 9 minus 11, you go from 9. So that's your starting point. And the direction that you're going to be moving is going to be to the negative side. So 9 going to 11 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is going to give you negative 2. And for the last problem, negative 2 minus 5. Negative 2 minus 5 is you start at negative 2. And you move 5 units to the negative side. So you have 1, 2, 3, 4, 5. And you'll have negative 7. Now, do you need to always use the number line when you are adding and subtracting integers? Of course not. Just like how you use your multiplication table. When you were first learning how to multiply numbers, multiplication table is like a new discovery, a great technology to use in multiplying 2 numbers. But after a while, once you have memorized the multiplication table because you are using it over and over again, you don't need to use it, so you can just multiply in your head. Just like integers. That's why knowing the basic of adding and subtracting integers, which is using the number line, will greatly help you when we work on algebra. Now, another thing that you need to remember about algebra is similar to learning a foreign language. So when you're working with foreign language, you need to learn how to speak it, you need to learn how to say it, you need to learn how to write it, and you need to learn how to read it. So in mathematics, some students are challenged with some of the mathematical problems because they don't know the words that is being used or thrown in the problem. We have additive inverse and multiplicative inverse. So these are some technical terms that we use in solving equation, but if you understood the meaning and why we need to know the properties of these numbers, it will make you understand algebra better. So we're going to be working with additive inverse and multiplicative inverse, and what does that mean? Additive inverse is a technical term or a mathematical term that we use to a number that you need to add to another number so that it will equal to 0. That is the additive inverse. And the multiplicative inverse is a number that you need to multiply to another number so that it will equal to 1. So those are the two number properties that we're going to be seeing and using in solving equation. The additive inverse and the multiplicative inverse. Now, this may sound really technical, but it's really simple once we use it with this example. Let's say 7. Think of a number that when you add to 7 will equal to 0. And what would that number be? Negative 7. So, negative 7 is the additive inverse of 7 because that is the number that when you add to a certain number will equal to 0, and that certain number in this example is 7. So it's equal to 0. So mathematically or technically we call it the additive inverse. So if I have negative 2, what number can I add to negative 2 for it to be equal to 0? Simply positive 2, or just 2, because negative 2 plus 2 is equal to 0. And that is the additive inverse. So if I ask you, what is the additive inverse of 5? What is the additive inverse of 5? Negative 5. What's the additive inverse of negative 203? 203. What's the additive inverse of 1/2? Negative 1/2. Right? So don't get too intimidated with fractions, decimals, because they're also numbers. We are so used to using whole numbers that when you see fractions or other form of numerical value, you think that it's a difficult problem to solve. But if you stick to the definition, it's actually really simple. So what is the additive inverse of 7.5? Negative 7.5. Got it? So that is the additive inverse, and the next thing that we're going to be working on will be the multiplicative inverse. And in this case, you need to think of a number, let's say 7, that when you multiply will equal to 1. Reciprocal is going to come into play. Do you still remember reciprocal with fraction? No? Alright, let's review. If I have 2 over 3, what is the reciprocal of 2 over 3? Okay, let's use a different term. If you flip this fraction, what is 2 over 3 when you flip it? Alright, reciprocal is just flipping your numerator and your denominator. So the reciprocal of 2 over 3 is 3 over 2. So if I have 7 over 8, what is the reciprocal of 7 over 8? 8 over 7. Now, if I have, more example, 3, what is the reciprocal of 3? 1/3. 1/3. Why is it 1/3? Because all whole numbers will have a denominator of 1. So the reciprocal of 3 over 1 is 1 over 3. So if I have 1 over 7, what is the reciprocal of 1 over 7? 7 over 1. Now, why is reciprocal important in the multiplicative inverse? Here's why. If I have 2 over 3, multiplied by 3 all over 2, it's going to equal to 2 times 3, which is, what's 2 times 3? 3 times 2, which is, and what is 6 over 6? 1. Because if you cancel common term in a fraction, it will always equal to 1. Got it? That is the importance of the reciprocal. It's not just Oh, because you just have to flip the fraction. No. The reason why you need to know your reciprocals is because that particular number is what you're going to be using later on when we are solving equation. Let's do this again. What number can you multiply to 7 so that it will equal to 1?
1 over 7.
Yes, 1 over 7. Because we know that 7 is 7 over 1. And if you multiply this, this will equal to 7 times 1 is 6, which is 7. 1 times 7, which is 7. 7 over 7 is 1. Got it? Okay. And that is the multiplicative inverse. So, if I have negative 2, what number am I going to multiply to negative 2 so that it will equal to, not 0, 1? Why should it be negative 1/2 and not just 1/2?
Negative equals positive.
Because negative is positive, and I'm looking for positive 1 and not negative 1. Got it? So, now that you know your additive inverse and multiplicative inverse, maybe you're ready for this. Pretty basic. Elementary math, maybe first grade math, maybe preschool math. If I have an equation like this, a box plus 5 equal to 7, what is the number that we can use to complete the box? Let's start with number 1. What is the number in the box so that it will equal to 7?
2.
Pretty basic, right? Therefore, for number 2, what is the number in the box so that we can have box minus 3 is equal to 8? 11? 11 minus 3 is equal to 8, right? Now, why am I showing you this? Because this is basically how algebra works. In algebra, we don't see boxes, right? What we see are x's. So that is basically how we are converting a basic math problem into something more flexible and something that could be a little bit useful for us when we work out word problems or equations or math problems that involves more complex operations. So this one is how we translate this into an algebra problem. So from a kindergarten math, now we have an algebra math. Now, how do we solve equation like this in mathematics? X plus 5 equal to 7. We're going to be using the additive inverse, which means you need to get rid of 5 or make 5 equal to 0 so that x will be by itself. That is the mathematical way on how we solve the equation. So, how are we going to make 5 equal to 0? Subtract 5. However, in algebra or in mathematics or in life in general, whatever you do on the other side of the equation, you need to do it also to the other side of the equation to maintain its balance. So you cannot just subtract 5 here and not subtract 5 on the other side. So we're going to do it here as well. And by doing so, this will turn into, so now it's just x. Because we don't need to write x plus 0, right? We can simply write x equal to, what, 7 minus 5? 2. And that is how we do things in algebra. And it may be a little bit tedious, but it will make sense because once we have more complex equation, this is how, or this is the step that we're going to be using to make it more systematic. So if I have x minus 3 is equal to 8, how am I going to solve it algebraically? Add 3 on this side, and add 3 on the other side of the equation as well. And by doing so, you're able to cancel out negative 3 because it's equal to 0 now. And now x is equal to 11. And that is how we use additive inverse when we are working with equation. Now, not all equation will be similar or will be just this, that we can translate into x plus 5 equal to 7 or x minus 3 is equal to 8. Sometimes we are given an equation like this. Now we're doing multiplication. Can you think of a number that when you multiply to 5 will equal to 45? That is basically what it's asking you. Can you think of a number that when you multiply to 5 will equal to 45? What is that number? 9. 9. And that's correct, because 9 times 5 is equal to 45, right? What is the number that you need to multiply to 2 so that it will equal to 10? 5. It's pretty basic and pretty simple. Now, how are we going to translate this into an algebraic equation? It will turn into this. 5x is equal to 45 and 2x equal to negative 10. And to be able to do this, all you're going to do is to think of the multiplicative inverse, which is multiplying 5 so that it will equal to 1. Not 0, but 1. What is the number that you need to multiply 5 with so that it will equal to 1? Is it 5 or 1 over 5? 1 over 5. And if you multiply 1 over 5 here, you're going to multiply 1 over 5 here on this side as well, right? Now, in mathematics, we don't use, well, we use this method most of the time, but in my case, what I do is I just skip it simple, and instead of multiplying a fraction, I will just divide both sides by 5, which is the same thing. Multiplying by 1 over 5 is the same as dividing a number by 5. Now, 5 divided by 5 is equal to 1. So this cancels out, so you have 1x, right? And what is 45 divided by 5? 9. So it's 1x equal to 9. And in algebra, we can simplify an equation by not writing 1 anymore. So it's simply x is equal to 9, because every variable or value of x will have a coefficient of 1. Alright? So, if I have 2x equal to negative 10, what am I going to do so that x will be by itself? Divide both sides by 2 or multiply both sides by 1/2, which gives you x is equal to negative 5. Alright? Wait. Let's go back. Did I write 5 here or negative 5? I wrote 5. So is 5 correct? No. It should be
I didn't see the negative.
negative 5.
I did not see it.
Alright, so negative 5 is the number that you multiply with 2 so that it will equal to negative 10. Just to make sure that we caught that. Alright, so those are the 2 basic steps that we are using in one step equation. It could be of this form or it could be of this form. And this particular fundamentals or algebra fundamental is what we are going to be using so that we can solve any equation or problem looking like this. Now, how are we going to make it a little bit more complex? Let's have an example like this. 1, 2, 3, and 4. See if you can answer those problems so that x will be by itself. Alright, so solving linear equation, also known as one-step equation or algebraic equation, is all about additive inverse and multiplicative inverse. Some of them you need to use one property, sometimes you need to use both. And in this case, for problem number 1, we just need one property, which is the additive inverse. So to solve for this one, we're going to what? Subtract 3 on both sides so that this will cancel out and x is equal to, what is 2 minus 3? Negative 1. That is why it's important that you know your integers, because it's not equal to 1, it's equal to negative 1. Alright, so that's number 1. Number 2, we'll have negative 5 plus x equal to 1. And we need to have x by itself, right? How are we going to get rid of negative 5? Yes. We add 5 here and up. And add 5 on the other side as well, because we need to have a balance. So by doing so, this will turn into 0, and we'll have x equal to 1 plus 5 is 6. So that's problem number 2. Now for problem number 3, we have 2x equal to 8. Are we going to be using the same technique for number 3, just like what we did on 1 and 2? Yes or no? No, we're going to be using the multiplicative inverse this time, right? So how am I going to get rid of 2 so that x will be by itself here? Am I going to subtract 2 on both sides? No. What am I going to do? Yes. I'm going to divide because this is not an addition of expressions but multiplication, and we need to do the inverse of it. So this cancels out because 2 divided by 2 is equal to 1. So we have 1x equal to 8 divided by 2? 4. Which is of course just x equal to 4. And number 4. So how am I going to get rid of that little 4 right at the bottom of your equation? We're going to multiply because it's all about inverses. If you're adding so that you can cancel out a number, you can also do its inverse by multiplication because fraction is division and the inverse operation of division is multiplication. So what number am I going to multiply with this expression so that I can get rid of 2? I'm going to multiply both sides by 2 this time because 2 is your denominator and we need to get rid of it, right? So by doing so, we are now dividing 2 and 2. And what is 2 divided by 2? 1, right? So we have 1x equal to 2, or x is equal to 2. So this is how we use one-step equation because you only perform a single step in solving for x. Just one step. It's either you're adding, subtracting, multiplying, or dividing. So if I have more, alright, can you please solve for the value of x for the 3 examples? Number 1, 2 plus x equal to negative 3. What are we going to do to have x by itself? Add 2 or minus 2? Minus 2. Because it's always the inverse operation, and 2 is positive, so we subtract 2 on both sides. So x is by itself. What is negative 3 minus 2? Negative 1 or negative 5? Negative 5. Because you start at negative 3 and you move 2 units to the left, it will end up at negative 5. Visualize your number line. I know I don't have the number line anymore, but it's good to practice. So these are just numbers that you need to make sure that you are seeing in your head. X over 3 equal to negative 2. What am I going to do so that 3 is going to go away? Multiply by what number? By 3. And that's correct. So it's safe to say that all you have to do when you are seeing equation like this, when there's a number in your denominator, multiply a number or that number to the both sides of the equation by the denominator. So multiply by 3, multiply by 3. This cancels out and x is equal to, since it's division, I will perform the step of copying the first fraction and multiply the reciprocal, which is 2 all over 9, right? Now, instead of multiplying across, I'm going to simultaneously multiply and simplify. Do you understand what I'm going to do? I'm not going to multiply across. I'm going to factor and multiply. How? 3, 7, 2 are all prime numbers, right? But 9 is not. What's the prime factors of 9? And why did I do that? So I can cancel the ones, and what is left? And that is my product in its simplest form. So I simultaneously simplify and multiply. And this is one technique that you can use so that you can easily multiply fractions. So this only works, well actually it always works for any fractions, but for multiplication you can do it at the same time. So let's try it with number 10. So number 10, it's multiplication, so I just need to multiply it 3 all over 5 times 4 all over 9. But I'm going to simultaneously multiply and factor, so I'm going to factor out my 4 and my 9. So I'll have 3 all over 5 multiplied by 2, 2, 3, 3. And by doing so, what can I cancel?
3.
What else? That's it. So my answer is 4 over 15. So that's one technique that you could use when you are multiplying and dividing. Simultaneously simplify and multiply by factoring. So what I did, perform prime factorization, okay? So always, or remember prime factorization when you are working with fractions, because it will make fractions or multiplying fractions a lot easier. Because instead of making or coming up with a big number, you're just breaking them apart. Important in mathematics. If you did not use the technique that I asked you to use, you're probably going to end up using a calculator. Why? Because the old method, you'll be multiplying 25 and 9 and 21 and 15, which is too big, right? Can you multiply this in your head? Probably not. But why multiply it in your head if you can factor? So, 25 is? 21 is? 9 is? 15 is? Now that you have broken them apart, it's a lot easier to work with because all you have to do is to collect your ones. And to collect your ones, top, bottom needs to be identical. What is the first pair?
5.
And
3.
do you have any other number to cancel?
No.
So you have 5 times 3 over, and that is the product of this number. That's why it's important that you know your technique and you know the reason or behind or the rationale behind the technique so that you can use them. All right, so use this when you're multiplying, dividing, and simplifying fraction, okay? Let's go back to this. Solve for x. Let's see if you get 3 out of 3. What's the answer for the first? Is that what you got? Any one of you? What about the second one?
12 or 12 or 1.
What about the last one?
23 over 20.
Okay. Now, why is number 1 wrong? So let's solve it. X minus 2 over 7 equals 12 over 7, right? What are we going to do to get rid of the fraction with x?
Add 2 sevens.
Right? And what is 12 over 7 plus 2 over 7?
14.
And what is, how many times 7 goes to 14?